Okie dokie, so now let's move on to the next lesson. How do we work with planes in geometry? This is a plane, a flat surface, okay? This is a line, okay. The edges of a plane are lines. If two planes are parallel, okay, then the edges are also parallel. Okay, so the intersection of two planes, let's say this one and this one, it's a straight line. The intersection of two planes, this one and this one, is a straight line. Now guess what? If there are two planes that are parallel to each other, okay, and there's another plane that intersects them, the intersection is a pair of parallel lines. See this? But you have to use your common sense. Right here, parallel lines. Got it? You see the parallel lines? Yes. Oh, okay. What else do I need to know? Sure. If a line is perpendicular to a plane and it's also perpendicular to another plane, then the planes are parallel. Okay? Okie dokie, so now let's start with the activity. Well, this is not the activity, I think. Okay, so we have that lines K1 and K2, okay, intersect at point E. This is the point E. Okay. So, which statement is always true? Okay, line K1 and K2 are perpendicular. These lines don't look perpendicular. It doesn't say that they're perpendicular. It says that this line M is perpendicular to this one. It doesn't say that these two lines are perpendicular. Otherwise, we will have the perpendicular symbol right here, which we don't. We have it right on top. Okay, perfect. So this is not. Line M is parallel to the plane determined by K1 and K2. Line M is parallel to the plane that these two lines determine. What the hell is he talking about? Like what plane? Okay, guys. You see how I can have lines K and lines K1 and K2 right here on my piece of paper? Well, remember when I told you that a plane is nothing more, you could think of a plane as a piece of paper. Well, these two lines are on the plane. And if I have another line, if I have line M right here, definitely line M is not parallel to the plane, to the piece of paper. So no, it's not. Okay then. So then line M is perpendicular to the plane determined by the lines K1 and K2. Well, let us just assume that we have the plane right here. Okay, better like that? So these two lines are on the plane. Now, line M is definitely perpendicular to the two lines. And remember when I said, if I have the two lines right here, let me zoom out. Okay, these two lines are on the plane. And the line M is perpendicular to those two lines. Guess what? Let's remove the lines. And line M is still standing on the plane that contains the two lines. So therefore, line M should also be perpendicular to that plane. I hope you understood. If not, then you have to rewind it. Oh, okay, let's continue. All right, what am I supposed to do here? Which of the following statement is true? Okay, here we go. Planes L and Q are parallel planes. L and Q are not parallel. Okay, planes L and Q intersect at line DE. L and Q intersect the line DE. No, they don't. They don't intersect at line DE. They intersect at this line right here. Okay. Point P is in plane L. Point P is in plane L. Hell yeah. Okay. Lines J and K intersect at point P. Line M is drawn so that it's perpendicular to lines J and K at point P. Which statement is correct? Okay, let's draw a visual. So you have two lines right here. Okay? So we have lines J and K. Okay? And then we have another line. Line M is drawn so that it is perpendicular. So it's perpendicular to this lines J and K. So which statement is correct? Well, let's see. lines J and K are in perpendicular planes. No. Once you have two lines intersecting, they are on the same plane. Okay. Line M is in the same plane as line J and K. Line M is not on the same plane. These two lines are on the flat piece of paper. This line right here is on a plane that is actually standing. So no. Line M is parallel to the plane. No. Line M is perpendicular to the plane containing J and K. Line M is perpendicular to these two lines that are contained in the piece of paper, right? Therefore, line M is also perpendicular to the plane. So here we go. Okay. If plane P, in plane P, we have a plane P, okay, lines M and N intersect at a point A. Again, the same thing. If K is perpendicular to the line M and the line N at point A, then line K is what? Well, which one is the perpendicular one? Line K is perpendicular to those two lines. So once again, you have these two lines and you have a line that is perpendicular, right? And we're talking about line K. Okay. So line K is contained in plane P. No, these two lines are in plane P. These two lines are in plane P. Plane P. Okay. Line K is parallel to plane P. I don't see it parallel. Perpendicular to plane P? Yes. Okay. Alright. Same thing. This is the same question. Okay. Let me see. Lines M and N intersect at point A. Line K is perpendicular to both. So we already know what the answer is. Just figure it out. Let's see what it says here. Point A lies in plane B. Oh no, sorry. Point A is not contained in plane B. Okay. So I have a plane and I have a point that is not contained. It's on top of it. See that? Okay. How many lines can be drawn through point A? Talking about point A right here. That will be perpendicular to plane B. How many lines can go through this point? Well, let's see. So I got one line right here. Perpendicular. Can I draw another line that will pass through point A and will also be perpendicular? No, only this line will pass through this point and be 90 degrees. The other lines will be maybe 89.9, 91.1, whatever, but they're never going to be perpendicular. So what does that show you? Only no two things can occupy the same space at the same time. Only this line can be right there. Okay, point A lies in plane B. How many lines can be drawn perpendicular to plane B through point A? So you got a plane, you got a point. So how many lines can be perpendicular to this plane that go through point A? Once again, no two things can occupy the same space at the same time. Okay. Let's see now. 27 didn't come out. I don't know what the hell. Now it's perpendicular. Which means correct. Okay, since we don't have those, not a problem. We'll move on to the next question. So please, no two things can occupy the same space at the same time. No two things can occupy the same space at the same time. And let's go with the next one. A support beam between the floor and the ceiling of a house forms 90 degrees. Okay? With the floor. Okay. The builder wants to make sure that the floor and the ceiling are parallel. Which angle should the support beam form with the ceiling? So let us do a representation right here. So I have the ceiling and I have the floor. Okay? And I have this support beam, okay, forming 90 degrees with the ceiling and the floor. So let's see now. Oh, sorry. This forms 90 degrees with the floor, the support beam. If these two lines, okay, two planes are to be parallel, then remember parallel, like parallel lines, transversal. So same side interior angles are supplementary. So if this is 90, this has to be 90 as well. So If this was 70, this would be 110. If this was 50, this would be 130, and so on and so forth, because they are same side interior angles on parallel lines. Of course, we're not talking about parallel lines, we're talking about the ceiling and the floor. So, which angle should the support be informed with the ceiling? Hello, 90. That's it. Oh, okay. No two things can occupy the same space at the same time. Alright. In three-dimensional space, two planes are parallel and a third plane intersects both parallel planes. The intersection of the planes is, hello, remember what I showed you? Two planes intersected by a third plane. Got it? So what does it form? Look. Definitely the intersection is not a plane, it's not a point, so it's either 3 or 4. Got it? Okay then, let's move on. Because this is, oh my god, it's such a long thingy here. Okay. This is for, oh, now I understand. This right here, okay, you could answer on your own, but because the choices are on the next page right here. So read it and you answer it. Now let's move on to the next one. Point A lies on point B. How many lines can be drawn? Okay, no two things can occupy the same space at the same time. Let's go to 29. If two different lines are perpendicular to the same plane, if two lines, okay, I have a plane. If two lines are perpendicular, meaning 90-degree angles, right? You are nice. Like that. So these two lines are perpendicular to the same plane, right? Then what kind of lines are those? I don't know. If two different lines are perpendicular to the same plane, they are, well, they parallel. But what else do I know? Collinear, they're not collinear. Congruent, no. Coplanar, yes. How do I know that? Well, think of it this way. I already gave you this drawing. Now close this thing. Guess what? These parallel lines are nothing more than the edges of your plane. Oh, so therefore they are coplanar. It's like putting, look, it's like putting two parallel lines inside this paper right here. They coplanar. Okay? Alright. What else? In the diagram, let me see, can I put the whole thing in there? Yes, okay. In the diagram below, line K is perpendicular to plane P at point T. So line K is perpendicular to plane P at point T. Which statement is true? Any point in plane P will also be on line K. Any point on plane P will also be on line K. Hello, so this point is on line K? This one? This one? This one? This one? No. Okay, only one line in plane P will intersect line K. Only one line in plane P will intersect line K. No, I could have a line here, a line here, a line here in the plane, right? Okay, all planes that intersect plane P will pass through T. That's not true. I could have one plane going through here, another plane here, another plane here, another plane here, another plane here. So no, that is not true. Okay, so what else? Any plane containing line K, well, let's have this plane right here. Let's say line K is in this plane right here. In this plane, right? So any plane containing line K is perpendicular to plane P. So if I go like this, will this plane be perpendicular to this one? Yes. Okay. In the diagram below, line AB is perpendicular to plane AEFG. Which plane must be perpendicular to plane AEFG? All right, let's see what I read. AB is perpendicular to plane AEFG. A, E, F, G. This plane. This line is perpendicular to this plane. That's all I know. Remember, in geometry, if it's not given or stated, then it is not. Do not assume anything yet. Okay, so which plane must be perpendicular to plane AEFG? Which of these planes? Well, let's start with this choice just for the sake of doing it. HDFG. 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 This plane. HDFG. So this in the box right here, does it look perpendicular to this plane right here? To me it does. But then what's wrong with it? It was never, I don't have any piece of information. All I see is my visual right here. I don't have any piece of information that says that this one is actually perpendicular to that. Okay then, so then what happens? Well, read what the problem says. In the diagram below, AB is perpendicular to plane AEFG. Oh, so basically anything that contains any plane that contains line AB will be perpendicular to this other plane. Okay then, so help me out. Well, ABCE. ABCE. A, B, C, E. ABCE. ABCE. This plane definitely is perpendicular to this one because it had said, we had information that it was. You understand what I'm saying? Alright then, so make sure that these questions you read carefully. And that's the end of this lesson. Now I'll see you on the next lesson, okay? Bye bye.